Hello everyone, my name is Anupam Sikarwar and welcome back to another video on the trigonometric series. And in last video we have solved the question number 2 and we have find what is the value of this radian in degree. Now we have question number 3, exercise 3.1, right? Let's go. So it's saying a wheel makes 360 revolution in 1 minute. Means in a car or bike, wheel is rotating continuously, right? So our speed increase. The more it will be revolve, the more speed we can generate, right? So it's saying that this wheel rotate 360 times in a 1 minute, right? So in 1 minute this rotate 360 times, not degree, times, right? So in 1 minute this wheel rotate 360 times, 360 times, right? So through how many radian does it turn in 1 second? So it's saying if in 1 minute it's rotating 360 times, so in 1 second, okay, how many radian does it turn in 1 second? So in 1 second, it will be rotate 360 by 60. Why? Because we are dividing it with a 60 seconds, that is equal to 1 minute, is equal to 6, right? So in 1 second this wheel will rotate 6 times, right? So when this wheel rotates one revolution, it cover 2 pi radian, that is equal to 360 degree. Okay, we are talking about degree. Okay, 360, this was the 360 times, okay, and this is degree. So when one revolution of the wheel covers 2 pi radian, right? So here we have 6 revolution, okay, it means it will cover 6 into 2 pi, that is equal to 12 pi. This is the answer. Okay, next question number 4. Find the degree measure of an angle subtended at the center of a circle of a radius 100 cm by an arc of length 22 cm. Okay, find a degree measure of an angle. Okay, so we have to make sure that the result should be in a degree. Okay, subtended at the center of a circle. Okay, so suppose we have a circle, right? So we have to find the degree. Circle radius is 100 centimeters. So let's draw a radius. This, it's a, let me just mix it, join it. This is 100 centimeter, right? The radius is 100 centimeter by an arc of length 22 centimeters. Suppose the arc is 22 centimeter. So here we can also draw one radius, that is also equal to 100 centimeter. So we have to find the angle. What is the angle forming here? That theta. So we have formula for this. Look, if we have to find the theta, then we can find it by L by R. And what is L and what is R? So you know radius is called R and this arc is a length. So L equal to 22. So we have R equal to 100, L equal to 22. We have to find what is theta, right? So theta equal to L by R in radian, and we have to calculate this angle subtended. Find the degree. Okay, we have to find the degree, but with this formula we will get angle in a radian. Okay, no problem. So theta equal to L, we have 22 by R 100, and if we want to convert radian to degree, then 1 radian equal to 180 by pi. So we will multiply this 180 by pi, right? So we can say pi is what? It's a 22 by 7. and if we have 7 here, we can move up. So we can say it 22 into 7. Okay, so 22 cancel. Now we have 180 into 7 by 100. So if I just cancel this, it will be 50, 90, 25, 45, 5 5s are 5, 9 5s are 45. Okay, so we have 9 into 7 by 5 radian, that is 63 by 5 radian. Okay, so this is the answer. And if you calculate in the degree and you go further, then you will get 63 by 5, and yeah, right, so 63 by 5, so 5 1 ja 5, and we have 13, 5 2 ja 10, we have 3. So we can write this also like 12 degree. Now we have 3 by 5, so 3 by 5, so 0 point, and it will be 30. Yeah, 3 by 5, so 5 6 ja, we have 30 cancelled. So we have 12 degree 3 by 5 minute, and 3 by 5 3 by 5 degree also. So 3 by 5 degree, if we will convert this in a minute, then it will be 112, right? So 12 3 ja 36, so we can write 12 degree 36 minute, 12 degree 36 minute. Let's verify our answer. Question number 4, the answer is 12 degree 36 minute, right? 12 degree 36 minute. Degree, yeah, so you see here 12 degree and 36 minute, our answer is right. Okay, now question number 5 says, in a circle of diameter 40 centimeter, okay, in a circle, we have a circle, and the diameter means a line that is connecting two point A and B through the center, right, that is 40. Okay, so here AB equal to 40, that is a diameter. The length of a chord is 20 centimeters. Suppose we have 2 points that is not crossing the center line, and the length of this P and Q equal to 20 centimeter. This is 40 centimeter, so we can say suppose this is O, so OA equal to 20 centimeter, that is radius. So length of the chord is 20 centimeter. Find the length of minor arc of the chord. Means we have to find this arc. Okay, this arc. So let's do, we know this is the radius and its value is 20, and know this is also 20. So the angle will be formed here, it will be 60 degree each, right? So we have theta equal to 20 degree. So it's asking find the minor chord. We have to find this arc. Okay, so you know, if you want to find the arc, just look at here, we have to focus on this area, and for that we know theta equal to L by R. We have theta 20 degree, and we need this in a radian. Okay, so we have 20 degree, and if we want to convert this in a radian, then we have to do what we can do. We have to in radian, so pi by 180 equal to L. What is L? This is L that we have to find. So L by R we have 20. So we can say L equal to 20 into 20. Okay, we have, so if I do one thing here, so it will be more clear. So we have to find L, right? So L equal to, we can say this is theta into R. So we can also say L equal to theta, that is 20, that is 60 degree. I have written this wrong. This is 60 degree. 60 into pi by 180 into 20. Okay, so 60 we can cross by 3, pi by 3 into 20. Now we have pi by 3 into 20, that is 20 pi 3, and this is the answer, 20 pi 3. 20 pi 3, here you can see. Okay, now the question number 6, and I think, yeah, this is the question number 6, second last. Let's see it quickly. If in a two circle, so let's draw the two circle first. We have circle 1, and if I copy this, we have two circle. Okay, so arc of the same length, so its arc is of a same length. Suppose this is a arc, okay, and this is a same length. I will just clear this, and now I will copy, so the arc should be look same. Okay, so both circle, suppose this is A, and this is B. So the length of arc in both circle is same. Length, subtended angle 60 degree and 75 degree, and suppose this is a center. Yeah, just a second. So yeah, okay, so the angle that is forming here, this is 60 degree and this is 75 degree. Okay, at the center, find the ratio of their radii. So this is x, for example. Let me just write it something like, this is theta in A, and in B, right? Theta equal to 60, 75, and the length equal to length, this area, that is the same, this is x and x, okay, common, and radius equal to r1 and r2. We don't know the radius also, right? So now what I can do, I know that theta equal to L by R, right? So for this case, 60 degree, for circle A, we can say 60 degree into, because it's in a degree, you see, in a degree, so we have to convert this in radian, right? You see here in above, this was also where is that, yeah, theta was in a degree, so we converted it by multiplying it by pi by 180. So we can multiply this by pi by 180 equal to L. What is the value of L? That is x. You see here, x by r1. Okay, so this is 180, so we have 3. So finally we get pi by pi by 3 equal to x by r1, right? So now we can clear all these things, right? And we have to only focus on one thing, that is for the theta 1, for the theta 1, for the a equal to, we get this value. Now we have for the b, for v we have theta equal to 75 into pi by 180 into pi by 180, that is equal to length we have x by r2, right? So if we do with 5, so 3, so we will get 3 2 just 6, and we will get 15, 3 5 just 15, right? And 3 and 6 and 0, right? Now we will do with the 5 5 ja and 12. Okay, so now we will get this 5 pi by 12. So now we have to find out what is the ratio of theta 1 by theta 2. Now we have to find out x by, let me just clear. Now we have to see the what is the ratio, right? So we can say that the first ratio pi by 3 divided by 5 pi by 12, 5 pi by 12 equal to x by r1, x by radius 1 divided by x by radius 2. We get it here, right? X by radius 2. So what we can do now, we can do, actually space is less here, that's why I prefer to solve on sheet. Now we can say, if we see this part, okay, so here we have pi by 3, and in below we have 5 pi by 12, so we can also write it by like 12 by 5 pi, right? So 3 4 ja pi khatam, then it will be 4 by 5. Now if we see this part, then we have x by r1, and here we have x by r2, so we can write x2 by r2, this is r2 by x cancel, so we will get x2 by x1. So the ratio of x1 ratio x2 equal to x1 equal to 5, so 5 ratio 4, that is answer. Okay, now question number 7, find the angle in a radian, okay, through which a pendulum swing if its length is 75. So you know pendulum, there is a fixed point of that, and there is a pendulum. Okay, when you swing that, so it will be go like this, and this it will be keep swinging like a jhula, you know, it will be keep swinging. So it's saying that this length is 75 and this radius is forming here 10 centimeter in first case. So what will be the angle here? So we know theta equal to L by R. So we don't know the theta, right? And the result will be in radian. Okay, so L, we have L equal to, this is L and this is R. So L equal to 10 by 75 equal to 5 2 is 10 and 1 3, 2 by 13, is it right? 5 2 is 10, 5 25, it will be 5. equal to 2 by 15 answer. Let's check our answer. 2 by 15. Okay, I will just leave the two questions for you. You have to just change here. Instead of 10, now you can put 15 and here 15. Then you can see what you are getting here. Okay, so that's it for the exercise 3.1. Now in next video we will cover exercise 3.2. Happy learning. Bye bye. See you in next video.